Hello everybody and welcome. Let's make sure that all what we learned in the previous videos is understandable and that can be applied when we answer some questions in the exam. So let's start with solving question number one. Question number one is asking the energy that increases as a simple pendulum swings upward towards the highest point of a swing is, it's the gravitational, electrical, elastic, or kinetic energy. Well, it's asking me what happens to the pendulum as it's going upwards. Well, since it's going upwards, we know that it will start losing its kinetic energy and it will start gaining potential energy. So the answer is clearly A. It will start gaining gravitational potential. Question number two. In which situation is mechanical energy conserved? Well, remember that we said mechanical energy is always conserved if there are no losses. And we mentioned some examples for losses. We mentioned friction. Friction is the main cause of energy losses. And we mentioned something called damping, which we see in springs, which is the internal friction between the springs molecules. So we want to check which of these situations has no energy losses, in other words, has no friction or damping. A parachute jumps from an airplane and comes to terminal velocity due to air friction. So there's air friction, so this can't be true. A box is kicked across a level floor and stops after sliding a few feet. Well, what stopped it? What stopped it is friction. So again, friction is here. So there must be losses in energy. Third of all, a spring oscillates up and down without any change in its amplitude. In other words, it keeps on going up and down perpetually because there is no damping. So this could be our correct answer. And finally, a ball is dropped to the floor and bounces back half the height. So it must have lost some of its energy when it hit the ground due to the friction, which transformed into heat, and sound, which is another form of energy. So it's clear that the answer here is C. Question number three. It takes an amount of work equal to W to compress a spring at a distance equal to X beyond its natural length. If the spring obeys Hooke's law, how much work is required to compress the spring at a distance equal to 2x? Well, some of you will jump direct and say, since compressing at a distance x needs W, then 2x means 2W. No, we must be very careful when we answer these types of questions. So potential energy or elastic potential energy is equal to half kx squared. So it's telling me that it used a certain amount of work. Well, actually the word work is another term for energy. So it used an energy equal to W to compress it a distance equal to x. So I'm going to say W in this case is equal to half kx squared. Okay, this is the first situation. Let's call it number one. In the second situation, it's asking me what happened to W if the distance this time is, instead of using x, we're using 2x. So situation number two, the potential energy or the elastic potential energy is equal to half k multiplied by 2x, and all of it is squared. Again, 2x, all of it is squared, not only the x, because x represents the distance. Since the distance is doubled, so the whole thing will be squared. Now, let's see what this does. We know that this is the same as half multiplied by k multiplied by 4x squared. If we just move this 4 here, because since there we have multiplication, so we can move it, this means that, let's continue solving here, the potential energy here is equal to 4 multiplied by half kx squared, which is the same as W. So the potential energy or the work needed is equal to 4 times the original work. So the answer is D, and it is not B. Again, concentrate when you deal with these types of questions. Write down the equation, everything will be more clear. Next question. Two blocks of mass M1 and M2 respectively are released simultaneously from the same height. Okay, so they are released from the same height. And we know when two objects are released from the same height, if air friction is neglected, they will reach the ground at the same time. In other words, they have the same velocity. They fall freely from with negligible air resistance. Okay, so we know that there is no air resistance while the blocks fall. What is the ratio of the kinetic energy of block 1 to the kinetic energy of block 2? Well, it's very simple. It's asking you to find the kinetic energy of block 1 over the kinetic energy of block 2. And we can say that the kinetic energy of block 1 is equal to half, let's say m1 v squared, divided by half m2 v squared. Okay, we can cancel the half and the half. m1 and m2 are different from each other, so we can't cancel them. Can we cancel this velocity with this velocity? The answer is yes. Why? Because they are equal. How did we know that? We know that two objects falling from the same height with negligible air resistance will have the same velocity. So the final answer will be m1 over m2, which is the same as B. Questions 5 and 6 are related. A pendulum swings to a maximum height h above its lowest point, which is y. So the lowest point is point y. As shown to the right, the mass of the pendulum is 0.05 kilograms. At point y, the bob has a speed of 3 meters per second. So it's telling me here the speed is 3 meters per second. Okay? And we already have the mass. The mass is equal to 0.05. Now, if the potential energy of the pendulum bob is 0 at point y, so at point y, there is no potential energy, and it's clear because it is almost on the ground. It's asking me to find the total energy, the kinetic plus potential, okay? But we already know that the total energy or the mechanical energy at location y will be equal to only kinetic energy, because it already mentioned in the question that the potential energy here is 0 and there is no spring that has elastic potential energy. So I can say that the kinetic energy is equal to half mv squared, which is straightforward. It is half multiplied by the mass 0.05 multiplied by the velocity, which is 3 squared. This gives us an answer equal to 0.23 joules. So the answer is C, and it's straightforward. Second part of the question, the maximum height h the pendulum can reach is almost nearly, okay, now we found the mechanical energy here. The mechanical energy at location y was equal to 0.23. Now the mechanical energy at this point, let's call it point H, for example. Mechanical energy at point H is going to be equal to the potential energy only. Why? Because it says at the maximum height, and we know at the maximum height the pendulum won't be moving anymore. So it's safe to say that mechanical energy at location H is equal to the potential energy at location H. Okay, now we know that the mechanical energy is always conserved, since we found the mechanical energy at location y and it was equal to 0.23. So I can say that 0.23 is equal to the potential energy, which is mgh. Again, 0.23 is equal to the mass, which we already know, 0.05, multiplied by the gravitational acceleration, which is 9.8, multiplied by the height, which is the unknown. I can just divide both sides by 0.05 multiplied by 9.8. I will divide the other side with the same value, 0.05 multiplied by 9.8, and I will get that h is equal to 0.45 meters above the ground. So the answer is C. As you can see, we're applying the law of conservation of energy. Question 7 and 8 are related. Objects x and y of mass m and 2m. So this is x and this is y. This has a mass of m and this has a mass of 2m. Sometimes drawing or sketching the question can really help. Now, they are attached to strings as a pendulum of equal length. So they are attached to strings of equal length. Now start thinking about velocity and them having the same velocity, okay? Because we mentioned before, if two pendulums had the same length, they would have the same time period because they have the same velocity. Now the objects are pulled back through the same small angle. Again, now this is object X and this is object Y, which is a little bit bigger, but we have the same length of strings. So this is M and this is 2M. They were pulled back to the same angle. In other words, they are the same height above the ground. Again, sketching really helps finding the answer. Now, they are released from rest, so they swing back and forth. The following represents possible relationships between the quantities for these two objects, A, B, C, and D. Let's see what question 7 is asking. The potential energy of the object at its lowest point of their paths is 0, and we already know that. How does the potential energy of object Y at the highest point of the path compare with the energy of point X? Well, it's clear for the potential energy of Y is equal to mgh. In our case, the mass is equal to 2m multiplied by g multiplied by h. The potential energy of object X is equal to also mgh, and this time we will replace m with the same value, m multiplied by g multiplied by h. So this is the potential energy at X. Well, it's clear that the potential energy of Y is double the potential energy of X. So let's see our choices. We can see that D answers our question for question number 7. So the answer here is D, because the potential energy of Y is double the potential energy of X. Question 8. How does the velocity of object Y at the lowest point of its path compare with that object X at the lowest point of its path? So it's asking me about the velocity of X and the velocity of Y. Well, remember we said that the velocity of the two objects only depends on the length of the string. And since they both have the same length, we can say that in this case the answer is C. They both have, it's the same for both objects. Question 9. A block of mass 2 kilograms slides down an inclined plane. Okay, this is kind of a new idea. The block starts at a vertical height of 3 meters above the bottom of an incline with a speed of 5 meters per second. So it already has a speed. Now it reaches the bottom with a speed of 7 meters per second. How much energy is lost due to friction? So it's telling me that there is energy lost due to friction. Let's start by trying to sketch the question. This is our incline. This is our box. It started 3 meters above the ground, and it had a velocity equal to 5 meters per second. Now, when it reached the ground, it's saying that it had a velocity equal to 7 meters per second, and now it's reaching the ground, so it's 0 above the ground. How can I solve this question? Again, the principle of energy conservation. The mechanical energy is always supposed to be conserved unless there's friction. So what we will do is that we will find the mechanical energy here, and we will find the mechanical energy here, and the difference between them is clearly the friction. So let's call this location A, and let's call this location B. Let's start with the mechanical energy at location A. It is clear that it has two types of energy. One of them is potential energy because it's above the ground, and the other is kinetic energy because it is moving. So I can say that it will be equal to the potential energy plus the kinetic energy. And we have the inputs to find all these values. The potential energy is equal to mgh plus half mv squared. Okay, I have the mass, which is 2 multiplied by 9.8 multiplied by the height, which is 3, plus half multiplied by 2 multiplied by 5 squared. This will give us an answer equal to 83.8 joules. So we found the mechanical energy at location A. Now let's study the mechanical energy at location B. The mechanical energy at location B is going to be equal to, what types of energy do I have? Well, the object is moving, so it has kinetic energy, but the object is not above the ground anymore, so there is no potential energy. So the only type of energy here is the kinetic energy, and I can also find it. The kinetic energy is equal to half mv squared, which is equal to half multiplied by 2 multiplied by 7 squared. The answer is 49 joules. Okay, we know that mechanical energy is conserved, but we can see that the mechanical energy at A is not equal to the mechanical energy at B. And the reason is that there is friction. So this means that the difference between mechanical energy at A and the mechanical energy at B is equal to the lost energy, because energy cannot be destroyed but can be transformed from one shape to another. So the answer will be simply like this. I will subtract 83.8 minus 49, and this will give us an answer equal to 35.8 joules. Well, this is our friction. And if we see the choices, the closest choice is D, which is 36 joules. Question 10. Which of the following forms of energy is most likely to be produced in some amount in nearly all energy transformations? Well, in all energy transformations in the real life, there must be some losses, and mainly these types of losses are thermal losses, not mechanical, because mechanical is not a form of energy. Chemical, not all objects are reactive. Electrical, not all objects can induce electricity, so the best answer is thermal energy. Final question. A car uniformly accelerates from rest along a straight line. Properties of the car that must increase include which of the following? Now, it's saying that the car is accelerating. That means that its speed is increasing. So let's start with the kinetic energy. Does the kinetic energy increase? Well, the kinetic energy is equal to half mv squared. And since v is increasing, this means that the kinetic energy, yes, is increasing. Second of all, potential energy. Well, there is no potential energy because the object is already on the ground and it's not changing its height, so there's no change in the potential energy. And finally, speed. Is the speed changing? Well, yes, for sure, because the object is accelerating. This means that the speed is increasing. So the answer will be 1 and 3 only. These are some questions. I hope this chapter is very clear right now. We will be solving more problems in general about this chapter. You can use them to revise just before the exam. So stay tuned for the next videos and watch the other chapters to get a full mark in the ACT Physics exam. See you then.